Today, in this short video, I'm going to try to explain how we would trace a long calculation to check why we get the results that we get when we execute a program that uses such calculation. We have seen in the past that programmers draw by hand what I call a hand simulation and the textbook calls a desk check to trace what the program does in memory one step at a time, one line at a time. In programming, when we have long operations and we trace a program, we have this additional tool that we call a binary tree or a decision tree. In this tree, what we do is we evaluate in which order the values get calculated by looking at the symbols in the order that they get evaluated by the computer. So the operations are evaluated from left to right, starting with anything in parentheses first, and then continued with multiplication, division, and modulus. Those three are at the same hierarchy. And then finally addition and subtraction. However, we have learned that the results can be affected by the data types that we use. Namely, we know that if we have an integer divided by an integer, the result will be an integer. So when you have a long operation, you may be thinking that your result will look a certain way, and you may see that the result is off by sometimes by more than some decimals because of the moment in which the integers become double in the long operation. So we're going to see how to trace for that. And so we have seen in summary that an integer gives us an integer. Then if we mix an integer and a double, or if we have two doubles, the result is going to be a double. So we need to look at both the order of the operations and the data type. So without having any numbers, I have the first example in which we have just the data type. So I showed you how the order of the operations play a role when we're mixing data types. So we don't have a double until here. Let's see when this double changes the data type of the sub result as it's getting calculated by the computer. So in this operation, in this long equation, we have something in parentheses. So this addition will happen first. So we have an integer plus an integer is going to give us an integer. And then we don't have any more parentheses. So we go back to the beginning, and this is the first value that we have. And we have an integer modulus an integer. So an integer modulus an integer will give us an integer. Incidentally, by definition, modulus requires two integers to get a result, even though Java for some reason works nonetheless. But by definition, to get a leftover, we need to have the two values to be integer data type. So otherwise we wouldn't have leftover because we would get a decimal result, a double result. So an integer modulus an integer will give us an integer. And then some people would tend to believe, okay, the addition happens first, but no, don't forget, we are at this hierarchy, modulus, multiplication, and division. So the next thing that would happen is the multiplication that is expressed at the end. So an integer times a double is going to give me a double. All right. So now I'm left with two sub-results that they will get added together. So I'm going to have an integer plus a double. And because I'm mixing the data types, integer and double, the result at this moment is going to be a double. So this double that we get, it only starts to be a double at this level, right? So it's not from the first calculation, it's from this third calculation. This is the first calculation, second calculation, third calculation, and fourth. So sometimes something that we do is we also write down the order of the calculation. Notice that I'm going by levels. I'm indicating the level of the operations. Okay, let's see another example now with numbers that have certain data types. So this second example has the same operators in the same order. However, I do not have parentheses for the addition. See, here we have an integer plus an integer in parentheses, but I purposely set up this example not to have parentheses. So we see how the binary tree changes. So the first calculation that is going to happen, we don't have parentheses, so then the next level will be multiplication, division, and modulus. So from left to right, modulus will happen first. 7 modulus 5 is 2 left over, because modulus calculates the remainder, if you remember, right? So 7 divided by 5 is 1. 1 times 5 is 5. 7 minus 5 is 2. That's the remainder. So I get a 2 as a result. Then the next operation at this level is the multiplication. So I have 10 times 20.0. So notice that the value is expressed with decimals, even with a point, even though the decimal has the value 0. Okay, we want to make it explicit. So then at that point we said I have an integer, I multiply it by a double, so then the result is going to be a double. So 10 times 20.0 is going to be 200.0. Okay, so now we have a 2, and a 200.0 that will be added together. So 2 from left to right, 2 plus 2 is the next calculation. It's going to be a 4, and this will get added to the 200.0. So 204.0 is the result. So that's how we would evaluate this calculation with numeric values that are integer and double data type mix. Third example, a little bit more realistic. So in a program where we trace it, we're going to have variable declarations with a certain value. So here we have the integer x is 3, the integer a is 10, the integer b is 5, the double n is 2.0. So we express the values with decimal places when they're double. Don't forget that. All right, my equation is a divided by x plus b divided by x minus x times n. So I would replace the variable names with the values that I have in my declarations. So a is 10, so I would spell it out, 10 divided by 3, which is the value of x. X has a 3, so I would spell out 3, plus the value of b, which is 5, integer, divided by the value of x, which is 3, integer, minus x, which is 3, integer, times n, which is 2.0. So 2.0. So I would have to evaluate the calculation with these values, with these data types. So from left to right, I don't have any parentheses, so I would start with a hierarchy of multiplication, division, and modulus. So from left to right, the first division that I have is 10 divided by 3, integer. So the result is not going to be 3.3333, it's going to be just plain 3. So at this level, I'm still having an integer because I'm dividing an integer divided by an integer, I get an integer. Next, I have 5 divided by 3. It's going to be 1 without decimal places because I have an integer divided by an integer. So this is the second operation, and I get another integer. So I'm losing decimal values as I'm having several divisions that are not precise, and they lose the decimals. Minus the multiplication of 3 times 2.0. And 3 times 2.0 gives me 6.0. So when I'm at this level, so see how I'm going with the calculations that are in the same hierarchy, I'm having them at the same level. I move down and I start from left to right with the addition. So I have an integer plus an integer is going to give me an integer 4. And then the next calculation, because I'm using a sub-result, I'm going farther down now. So I'm doing the 4 plus the 6.0. At this level, now I have an integer minus a double. The result is going to be a double. 4 minus 6 is negative 2. And because I'm mixing the data types, the result is going to have the decimal places. So it could happen that somebody would expect a different result because we needed to have the decimal places for the results. And when they see negative 2.0, they go, what is going on? Why is the value wrong? So when we trace it and we evaluate that an integer divided by an integer gives me an integer, maybe at that point we realize that some of these values would need to be typecasted. And that's the moral of the story.